Hi, I'm Omnik. I will be solving educational code first round 153 and explaining what I'm doing. But first, I want to say that you can support me financially if you want me to continue doing some educational videos. Also, you can try to ask to say stuff in the videos. For example, exactly as written, I would like to thank X, Y, and Z and Agni Mandur for supporting me. Problem A, apparently about regular bracket sequences. So that's just the definition. You given bracket sequence, find a regular bracket sequence of length 2n such that S does not occur in T as a continuous substring. Interesting. I guess there will be just like a lot of cases. So there can be answer no for this case because somewhere in regular bracket sequence there must be opening bracket and then closing bracket. For all other cases, I think it's always possible. If there are two consecutive opening brackets or two consecutive closing brackets, then we can construct a correct bracket sequence that is just like opening, closing. So like pairs of brackets. There are no two consecutive equal characters, so the given string cannot be a substring. Otherwise, in the given string, like it should be alternating, so there should be a place where it is closing and then opening, and in that case we can put just like n opening brackets and n closing brackets. Yeah, so there won't be like closing and then opening bracket. Also, I assumed that n is given, but oh right, n is the length of S. Okay, so n is given. Okay. So yeah, after reading a string, if it is just opening, closing, then no. If there are two consecutive equal characters, then just alternating like this. And otherwise, it means that there would be closing and opening, and then we can do something like this, just n opening brackets and then n closing brackets. How to check if there is to consecutive equal characters, then just alternating like this. Also I should print yes, and I'm switching back to print. Well, it's not a lot of input and output rate, like 10 to the 5th strings should be fine. Should not be too slow. Otherwise, actually I can print yes here. And so here I can just print an opening brackets and then and closing brackets. Okay. Not the nicest problem, but well, I can't even say it's bad. Like, the statement is nice, but like the amount of case bashing for the first problem in the contest, not great. Problem B. About some coins, apparently. Want to pay exactly M. We have two types of coins worth 1, some number of regular coins of worth 1, and infinitely many fancy coins, and coins worth K. Again, some number of regular coins and infinitely many fancy coins. Wants to make the purchase that there is no change, so exactly M. He wants to spend as little fancy coins as possible. Okay, again, not very interesting problem. So if we fix the number of coins that worth K to be something, then we know how many coins that worth 1 we should use, and then obviously we want to first spend regular coins, then spend fancy coins. We cannot just iterate over the number of over split into coins of value K and 1, but it should be clear to see that it doesn't make sense to spend a lot of fancy coins that worth 1. Like, to be exact, if we do spend at least K fancy coins that worth 1, we can instead remove all of them and spend 1 fancy coin of worth K. And that always strictly better because we reduce the amount of fancy coins we spend. So we should always spend strictly less than K fancy coins that worth 1. On the other hand, the remainder modulo K of the number of coins that worth 1 we will spend is fixed. That's just the cost of the item we want to buy modulo k, because coins that worth k, they have remainder 0 modulo k always. And so it also like doesn't make sense to use two little coins that worth 1. If we use at least one coin that worth k and we have at least k unspent regular coins that worth 1, we could exchange a coin that worth k for k not fancy coins that worth 1 that will non-increase the amount of fancy coins we use. So basically we will try to spend almost all regular coins that worth 1. If that's enough to pay for the item, then we can just use that, and the answer is 0. Otherwise, we want to leave less than k of them, but also we do not want to spend more than k fancy coins that worth 1. But that actually means that there are only two options, like the maximum number of regular coins that worth 1 with the correct remainder modulo k without using any fancy coins, or like k more coins that will use fancy coins, but like some small number of them, less than k. Increasing further doesn't make sense, decreasing also doesn't make sense, so we only have two interesting options. And we should just check both of them and see which one is better. Again, some ifs, and well, the problem is not interesting for me. It's safe to initialize the answer with m, because we can always use just m fancy coins that worth 1. If we have enough non-fancy coins that worth 1, then the answer is just 0, and we can just print it if we want. Let's instead do it like this. Okay, otherwise we don't have enough, so let's find the maximum number of non-fancy coins that worth 1 that we can spend. That is the biggest number at most x that has the same remainder modulo k as m. So it's something like that, but that number can be greater than x, in which case I want to decrease it by k. And we need to be careful, this number can be negative. Like if it is negative, then I shouldn't update the answer with that option, because like it is impossible to use negative number of coins, and like that can actually happen. For example, if k is very bigger than m, then we cannot use coins that worth k. And if, let's say, we don't have any coins, unfancy coins that worth 1, we would have to spend fancy coins that worth 1. But we kind of could say, okay, instead of doing that, let's just use one fancy coin or unfancy coin that worth k and like get change, but that's forbidden. So if p is negative, then that's not a valid option. But if p is non-negative, then I can update the answer. With what should I update the answer? So of coins that worth one, I'm only using non-fancy coins, because like, after that I know that p is at most x. So the only fancy coins I will be using are fancy coins that worth k. How many coins that worth k I need? So I used p coins that worth 1. That's the rest of the price that I should pay. So the number of coins will be this divided by k. But I also have y non-fancy coins. And so like minus y, but again, that can become negative if we have enough non-fancy coins to just pay everything. So I'm taking maximum with 0. Okay. Now, so now the other option is to spend a little bit of non-fancy coins, no, of fancy coins of cost 1. I will have to spend k more coins. I can assert that it is still not greater than the cost, otherwise we will be in this case. And again, updating the answer with, well, something similar. That still calculates the number of fancy coins of worth k, because I increased p by k. That number decreased by 1. Maybe it's still 0 because of maximum. But now I also spent fancy coins that worth 1 and exactly p minus x of them. I know that p is strictly greater than x. So, well, technically you can write like maximum of 0 and this, but it is not needed because it is non-negative and actually strictly positive. And after we tried both options, that will be the answer. Problem C. Alice and Bob are playing a game. They have some permutation. They also have a chip which can be placed on any element of the permutation. As Bob make alternative moves. During the first move, Alice chooses any element of the permutation and places the chip on that element. During each of the next moves, the current player has to move the chip to any element that is simultaneously to the left and strictly less than the current element. If a player cannot make a move, that player wins the game. interesting. Then some weird phrasing, but I guess like we need to calculate for how many starting positions Alice wins. And actually, like after Alice places the chip first, it's Bob's move, so kind of Bob moves first. Well, it's pretty standard game on graph. For every position, we could just consider all the moves and build the graph on which they are moving the chip. For example, if we let's take some permutation from sample. Why are they all so short? Okay, let's take some other permutation. So here corresponding graph would look like this. From 2 we cannot make any moves, from 3 we can move to 2, from 1 we cannot make any moves because there are no smaller number, from 5 we can go to all the elements on the left, and from 4 we cannot go to 5 because it is bigger, but we can go to all the other elements on the left. And since all the edges are to the left, we have this acyclic graph, and we can like look for any for every state, determine is it winning or losing. So if we are here, this is a winning state because we don't have any moves. Then this one is losing because we have only one move and it goes to the winning state. This one is winning, this is losing, and no, both of those are winning because from them we can move to this state, which is losing for our opponent. So that is what called retroanalysis, and we can do it in like the size of the graph. The issue here is that the size of the graph is quadratic. We are only given a permutation of size n, but the number of possible transitions can be quadratic. But we can still use this logic to determine winning or losing state for all the elements. We can go left to right, and for each element determine whether it is winning or losing. In which case the position is winning. Either it is like there are no moves, so it is this element is smaller than everything before it, or it is winning if there is a move to a losing position. So let's say we have reached some place. So we're going left to right, determining some winning and losing states, and now we are here. If this element is smaller than everything here, it's winning. Otherwise, we need to check if we can move to any of the losing states. But since we can only move to the left, we only need to consider the states that we have already visited. And well, technically we could just state all of the losing states in some kind of set, and then we need to check if we can move to any of them And for that, actually we want to check if there a losing state to the left of our current position that is that contains smaller number. But actually for that we just need to store the smallest losing state. So we can just store two numbers, just minimum one prefix and minimum of all losing states up to this point. And if the next number is smaller than global minimum or bigger than losing minimum, then it is a winning state. Otherwise, it is a losing state. So that would work in linear time. We don't even need to store the permutation. Just do it online while reading. And we are interested in the number of losing states because after we place the chip, it is Bob's move. So Alice would win if Bob loses. So we start at the losing state. So we read the next element. If it is smaller than global minimum, if it is smaller than global minimum, then it is a winning position. We do not have to increase the answer, but we do have to decrease the global minimum. If it is bigger than global minimum but smaller than minimum of losing positions, then it is a losing position in itself. The RAM moves from it because there is a smaller element, but all the smaller elements are winning positions, so it is a losing position. We increase the answer and it will become new lose minimum because it is smaller than previous lose minimums. And otherwise it is a winning position and we don't have to change anything, so we can even do it like this. Problem D. Given the binary string and the length is up to 100 and there are no multitests. Interesting. Kind of suspicious. Let's call a binary string balanced if the number of subsequences 0, 1 equals to the number of subsequences 1, 0. Okay. You can perform the following operation any number of times. Choose two characters and swap them. Task is to calculate the minimum number of operations to make the string S balanced. Additional constraint on input, the string S can be made balanced. Yeah, it wasn't clear if it is always possible to do. kind of feels like maybe it's always possible in some small number of operations. If I swap two consecutive characters, if they're equal, obviously nothing changes. Otherwise, if it was like 0, 1, I swap them, and all the subsequences of lens2 will stay the same, except like, the subsequence that was right here, these two elements, and we changed 0, 1 to 1, 0. So the balance changes by 2. Or maybe like so many clarifications. Maybe you can just do simple DP. Like I need to store. If I go left to right and just build the string, and to store the number of zeros on the prefix, the number of ones on the prefix, that fixes the length of the prefix, and also the balance between like number of subsequences 0, 1 minus number of subsequences 1, 0. And the I'm storing in the DP the minimum cost, kind of, which is like the number of places where I changed 0 to 1, for example. I know that the number of zeros and the number of ones cannot change if I only do swaps, and if like I have some zeros that I need to change to ones, I will have the same number of ones that I need to change to zeros, and so I can match them and do this many swaps. So I'm storing number of zeros, number of ones, balance. That's it. Number of zeros and number of ones are both up to n, even like their sum is up to n, and balance is up to n squared. Like from minus n squared to n squared, but actually like it's from n times I guess like n squared divided by 4 even. But in any case, like the number of transitions is constant, so it's like n to the 4th with very small constant, like smaller than 1. And that's it. Why is it not multitest? Unclear. So just a DP. I will be very greedy, which is not a great idea when I don't have to optimize anything actually, but yeah. Okay, so I'm in a state with prefix of length I and j zeros, therefore j is at most I. So I have I minus j ones on the prefix. And the balance is x if so because my balance can be both positive and negative, I want to shift it so that all the possible values are non-negative, so I am starting somewhere in the middle. So I want to make the transitions. So check that the state is reachable. So if I'm putting another 0, then the number of subsequences 1, 0 will increase by the number of ones on prefix. And the number of zeros will increase by 1, and the balance will, let's say, increase by I minus j. Otherwise, the number of zeros will not increase and the balance will decrease by j. So this checks if my new character is different from the old one, then I should increase the DP value. I guess then I will have to print minimum of DP values, or like not minimum. I just need to know where I look. Divide by 2 because like for I'm counting the number of positions in which the character is different, so the number of swaps needed to fix it is 2 times less. And now I need to calculate the number of zeros in the initial string and the balance. Oh no, the balance must be 0. Okay, so just the number of zeros. And then print dp0j, the number of zeros, and the balance is 0, which is my constant z. Not sure the samples are great, but okay. Also, I'm like pretty sure that this would be fast enough for an up to, I don't know, 500. Like the second parameter can be bounded by n over 2 because, well, we only need to do it up to the number of zeros in the initial strings, but if there are a lot of zeros, then I can store the number of ones instead. This is like even after doubling, it's n square over 2, and moreover for shorter prefix it's even less than that. So like for prefix of size k, the number of zeros is at most k, and this thing is up to k square over 2. So the whole thing would work in n to the 4th divided by 8. Okay, maybe not 500, but 300. Should be fine. Okay, next problem, problem E. Oh no, again some strings. Again, string, text editor, it sounds awful. Cursor between two adjacent letters. The cursor can't be placed before the first or after the last letter. Interesting. In one move, you can perform one of 3 actions. Move left, move right, and we still cannot go to the left of everything and to the right of everything. Okay, and the third action is interesting probably. Let x be the letter immediately to the left of the cursor and y be the letter immediately to the right. Choose any pair of adjacent letters such that the left of them is x and the right of them is y. And move the cursor to the position between these 2 letters. So basically, for any, if we have substrings of length 2 that are equal at 2 places, we can jump from the position in the middle of the one substring to the middle of the other substring. Ask queries. In each query, you are given 2 integers f and t. Calculate shortest distance, right? Yeah. So we have this graph, which is like linear graph plus some special stuff. Can it be important that those are letters? Lowercase Latin letters. So like all positions are split into at most 26 squared classes, and inside the class you can like jump to the position like with the same class in one operation. Kind of feels like the alphabet is big enough so that like it doesn't matter that those like the class is described by two consecutive letters. And well, it could have mattered if like we have two consecutive letters, and if like this is the same class, then we know that the right letters are the same. So like if the next is the same something, but it feels like it's not important. Like basically I just have like n-1 vertices, each one has a color, one of 576, 26 square, no, 26 square is 676, yeah. And I can move one left, one right, and jump to different vertex of the same color. And on this graph, I need to solve shortest path problem a lot of times. I guess like the limitations are not very big. So like I can construct kind of auxiliary graph. So for every color, for all the vertices of this color, I can connect them here and make, well, for example, the costs of those edges are 1 and the costs of these edges are 2. So that like when I want to jump using some color, I like go here and then here. And so the cost of that action is also 2, just like for just moving along the line. So on this graph, which is of size n plus alphabet square, but let's call this so the size of the graph is n plus m. N plus m vertices and 2n edges, right? But what's important is that like if there are no those additional vertices, then the graph is very simple, just a bump. So either we are just moving along the string, or we have to use some of those special vertices. And the number of special vertices is m, that is not that big. So, for example, how I can see a solution to this problem work is for every special vertex, I will precalculate distances to all other vertices in m times 1 to BFS, so like linear time. And then for each query, I'm either just going on the bamboo, or I must visit one of those vertices. I can iterate over all of them, and for everyone update the answer with like shortest path to that special vertex, and then from special vertex to the end. So each query will be of m. The solution is very simple. The only thing to worry about is that it can be a bit slow, and it does require a lot of memory. Actually, it doesn't require a lot of memory. If I can do that offline, I can like do it one by one. Try the color, calculate all the distances, update all the like answer to all the queries, forget about it. So the memory actually will be linear. That would be a bit more interesting problem, and there shouldn't be any problems with time limit. It's like 10 to the 8th. We have 5 seconds. Well, I guess like I would need 10 to the 8th pushbacks, which is not that great, but I think I will revisit. And yeah, I will implement the version with linear memory. I just think that it's kind of cool. So I initialize the answer with 2 times just difference between v and u. Now I want to construct the graph. So there are two parts. First, there is just linear bamboo. And also for every position, I need to take the ID of this substring of length 2. So it's 26 times at n to it, and then at h v1. Okay, now in this graph I want to calculate shortest distances from every special vertex, and after I do that, update all the answers using those calculated distances. And since I multiplied all the distances by 2, I need to print them divided by 2. So that's 0 kbfs. I think should be fine. Okay, and the last problem. Well, it's just yes or no. 10 seconds. Given two n tuples of values a, b, c, a and b are positive integers, and c is a bracket. Exactly n tuples have opening bracket, and other n have closing bracket. You are asked to choose two positive values x and y, not necessarily integers, but strictly positive. And sort the tuples in the increasing value of a times x plus b times y. So, well, this looks like scalar product. If several tuples have the same value, you can place them in any order among themselves. Is it possible to choose such x and y that taking bracket c from the tuples in the resulting order produces a regular bracket sequence? Well, that sounds like geometry problem. Not even a very hard one. Just like we have points on the plane whose values, whose coordinates a and b, and in each point there is a bracket. You need to choose a direction and sort the points by scalar product, like basically according to that direction. The direction must be like strictly in the first quadrant. We can check all the orders. I don't really understand what the problem is. Just go and do that. So like we will start with basically horizontal order. Well, we are not allowed to make it horizontal, but like almost horizontal. And then we will rotate the vector of direction, and there will be events when we need to swap the order of 2 points. Well, I guess I need to check that at some point I get a correct bracket sequence, so I guess I need to store balances. But actually, like, all the operations are just swaps of 2 consecutive points. Well, it's not exactly true. Which is a bit sad. Because we can have like collinear points. We can even have coincident points. And also for the given direction, like equal points can be in any order. So I want to like first put opening brackets and closing brackets, but still like think that if I can just store the balances, and so I'm interested in the situation when there are no negative balances. When I stay in some direction, there will be like segments of points in order that I need to, well, basically reverse their order. But in that point, like when I have chosen that one given direction, on all those segments I can reorder them as I want. But that would mean that I first put all the opening brackets and all the closing, and if both endpoint balances were non-negative, then everything between will be non-negative, because like I first increase then decrease. I will stay above the line that connects those 2 points that like with non-negative y coordinates, so it will all stay non-negative. So inside that segment, I know that everything will be non-negative, so I can just ignore those values for now. So I will have array of balances. I know which segments I need to reverse right now. So like I need to be careful to consider all the events with the same direction at the same time, but that, yeah, I need to do that. It shouldn't be a big problem that I need to do that. All right. So all the positions inside the segments of like, currently equal vectors I'm just ignoring when checking for is it a correct bracket sequence. So is it true that all the balances are non-negative? So I just will go through all the points that I need to ignore, turn them off, kind of check that there are no negative. Yes, if there are no negative, then just print yes. Otherwise, well, this is not a good direction, so I just need to reverse the order, and like reverse in one segment will not change the balances on the borders. So like after reversing, I need to change the balances inside this segment. But like the total length of the segments I will reverse is n square. So all of that will work in n square, like after I sort the events. So sorting the events is n square log. And after that, everything is just linear in the number of events. Yeah. It is not very pretty, but it shouldn't be hard. Even in terms of implementation, I don't think it's hard. But all of that is true only if like there are no coinciding points, because them they are always in the order I want. So like first all opening, then all closing. But that just means that I can merge them initially. So if I have 3 opening brackets and 5 closing brackets at some point, I will just say that in this point I have -2 to the balance. Well, not fun, but I certainly have enough time to implement that. It's an educational problem, as promised. I don't need a lot from point what do I need? I need to be able to sort them by angle, so cross product. Need subtraction. Product and rotating by 90 degrees, I think. And I certainly need some kind of simple sorting to make those to merge equal points. I also need to sort them initially, like in horizontal direction, so I can do that now. So if x coordinates are not equal, then the smaller ones should go first. Otherwise, like my direction is horizontal with just a tinge of upwards. So otherwise I'm sorting by y coordinate. Right, right. Alright. So there will be some struct event which will have the direction and the ID of IDs of 2 points that we need to swap right now. And I want to be able to sort those events by the angle of the direction, so by the cross product. Okay. I'm getting point xy, and character will determine the balance. So this is a pair of point xy, and if it is opening bracket, then the balance is 1, otherwise it's -1. Okay. Now I want to contract or like merge the points that are in the same position. So now they merged, and I now have n different points. They're already sorted in the correct initial order, so I can just leave them like that. I will also need during the process, when I'm rotating the direction, I will maintain the order of those points and the current balances and everything. But like in the, I don't want to change this order. So I will start another array order. Well, I will explain now why I don't want to change this order. Basically, for every point, I assign the ID, which is index where it is stored in this array right now. So I don't want to change that array. So the ID is fixed. And in the events, I will store the IDs of points I want to swap, because well, when I create the event is the direction when those 2 points are on, like, they have the same value. When we are rotating, like if we have 2 points such that one has bigger x coordinate but the other has bigger y coordinate, when we are like almost horizontal, the one with bigger x coordinate is bigger, further down in this direction, but when we will arrive at the almost vertical position, the one with bigger y coordinate will be further on. So somewhere between, there will be a direction where they are equally far away in that direction, and at that point we need to swap their order. And it's not hard to understand what is that direction. It's actually like it is perpendicular to the segment that contains segment that connects those 2 points. Because it's easy to see that those 2 points will have the same projection on the direction that is perpendicular to the segment that connects them. So like for every 2 points, there will be a single event. Maybe there won't be an event that interests us because like it has negative x or y something. So there will be at most one. But anyway, like for pair of points, I can create an event. But at that point, I don't know what will be their relative positions in the order. I mean, the relative positions I know, but I don't know on which positions they will be in the current order. That's the problem we are trying to solve, basically. So I will store their IDs. But then when I want to swap them, I need to know where they are in the order. So for every ID, for every point, I will store current position in the order. So basically I'm storing the order of IDs and the inverse permutation for every ID, where is it in the order. Each event stores IDs of the points that I need to swap. By those IDs, I can find their positions and perform the swap and maintain the balances and do all the checks. That's the idea. Okay, so now the points are here. To store the order, and I need to start the inverse permutation. How would they call it? Pos for ID. I also should calculate the balances. Why not now? Okay, so during the scan line, I will maintain the balances and maintain how many of them are negative. If at some point there are 0 negative, then I'm just doing return true and that's it. Otherwise, like in the end, I will do return false. So now I want to create the events. Since I can't have strictly horizontal, strictly vertical line, like everything is kind of between them. The points that have the same x coordinate and the same y coordinate, they will always be compared in the same way by their other coordinate. Also, like right now, I don't know in which of two directions like this vector is looking. Like, basically, I took a vector that is orthogonal to the one that connects those 2 points, but there are 2 such vectors in the opposite directions. And also, it is possible that this vector is not in the first quadrant. Like if one point has both coordinates smaller than the other one, for all the directions in the first quadrant, when x and y are positive, it will be smaller always. But when we go to the negative coordinates, it will become bigger. So I want to make this point like to have both coordinates positive. So if x coordinate is negative, then I want to rotate it like take the opposite vector like this, but after that y coordinate can still be negative, and that just means that this event doesn't exist for us, because we only consider events where we're still in the first quadrant. So we just do continue. Otherwise, yeah, it's a valid event, and we need to add it to the list of events. Sorting all the events by angle. All right, now like the main part. I'm going through the events in sort order, but I need to be careful and do all the events with the same angle at the same time. So I will now locate the next segment of events that I want to process right now. And we can even like put that in another function, but it will be called only here, so it doesn't really matter. So okay, now I want to process the segment of events from L to R. How to do that? So I will run through them and look at all the pairs of elements that I need to swap right now, and like where they are located in the current order. And I know from the logic of the process that is happening that I will have to swap the pairs like for some segments of points that are equal for that direction. All of them were in some order. Like if we go just before that direction, they were in some order, and if we will move just after that direction, all of them will swap their relative order. So I will have I have those segments of kind of equal points right now, and the order after the operation will be reversed on every segment. I want to figure out what are those segments. And for that, I should, well, use some kind of logic to make a union of those, of the operations that I need to do. Right now, I know all the swaps. I'm given all the pairs of elements that lie in the same segment. The most logical way is to use DSU. Literally, I have information that these two elements are in the same segment. So that's literally finding connected components. And I can do that, but I need to be careful. Basically, the problem is that I have n-square events. I don't want for every time I do some swaps to do linear checks. The time that I use should be proportional to the number of the events. So the total size of the segments I will be reversing. So I cannot create new DSU. If I use one DSU and then clear all the positions that were changed, that would be fine. It's possible to use something simpler. Since I have all the pairs in for every segment, I can just get all the positions in between the elements that are swapped. Actually, it would be fine to just take all the positions between consecutive elements that should be swapped, and then just sort them and look at the consecutive position between consecutive elements, and those will be the segments. So that's what I will do. So event says that I should swap points with IDs V and U, but that are not their positions right now, that are their IDs. To get the position, I use the array position for ID that I will be maintaining. So I know that I want to swap positions. Now there are positions V and U, and if they are consecutive, I can remember that we need to swap V and V plus 1. That sorting adds additional logarithm, but it is still the number of events I'm processing right now times logarithm of that number of events, and it is still n square log. I already have sorting here. So now this thing. Those are positions between consecutive elements that I inside the segments that I will be reversing. I want to find the actual segments. Alright, now I know the segments. Now for every segments, well, in the end, what I want to do is I want to reverse each of the segments and like recalculate the balances where they change, so also inside those segments. But I also need to consider that like with this particular direction, in every segment I can choose any order I want for the purposes of getting a positive answer, getting a correct bracket sequence. And for that I said that like to check that I will just ignore all the balances that are inside those segments. So for every segment I will run all the points in between, and if I had negative balances there, I will ignore that for now. And if I don't have any bad balances, just return true. Okay, so now I do have negative balances still, even though like on every segment I can choose any order. So I have to move on. I need to reverse every segment and recalculate balances and count them in SYN-Tibet again. I want to reverse segment from L to R and recalculate balances inside and calculate them in SYN-Tibet again. So first I will just well, basically I can say like reverse the segment from L to R in the array ort. And store position for ID for all the elements that it changed. So for position I, the element here now is ort I, so for this ID its position is I. Also balance on position I plus 1 is balance on position I plus what contributes the element that is now the element that is now on position I, which is ort I, and what it contributes is written in its ID second. And also count them in SYN-Tibet, but only those that are strictly inside, the ones that I turned off to check if everything is good right now. redefinition. Just L here. Okay. Well, let's praise it. I didn't make any mistakes because it will be very hard to debug. Yeah. The increasing. Okay, let's just go through the code once. This is the number of inside points, so the length of the segment is bigger by 1. Usually when the authors don't hate the participants, or like, well, in those kinds of problems, there is usually a problem. Like, you're not just asked to look at all the orders that you can get by choosing some direction and sourcing points in that direction. That's basically what this problem asks. And so to minimize the hatred from the participants, it is usually guaranteed that there are no 3 collinear points and certainly no coinciding points. Like, I would guess that coinciding points must be a serious problem for some participants. Like, if they just forget about their existence, like, it can't be fixed by anything, basically. So, like, yeah, there are no collinear, no 3 points are collinear, and so, like, every segment that you need to reverse is actually once to just do a swap. That wouldn't help much in this problem. You still would need to process events in batches because because of this part. When we do the events, we need to ignore the balance that is inside. And like, it can happen that basically the graph of balances looks like 0, -1, 0, 1, 0, and you need to flip like first 2 elements and last 2 elements. And like, before the flip it is bad, there is -1. After the flip it will be 0, 1, 0, -1, 0, also bad. But inside, like, for this particular direction, you can do 0, 1, 0, 1, 0 only for this one direction. And so, like, you need to basically ignore the balances that are inside the segments that are reversed. That's what I do here, basically. And so you can't just do events one by one. There is still a need to do them at the same time. But at least you wouldn't need to do this part. Like, you're just given all the swaps that you need to do, and like, each swap is the swap of 2 consecutive elements. And so, like, instead of finding the segments are always of 1, 2, and there is just one swap in every segment. But yeah, since it is an educational problem and there is not much else to this problem, it is just like asked to implement this thing. Yeah, they decided to hate the participants a bit and allow coinciding points and collinear points, which makes the implementation a bit worse. Not the greatest contest by my standards. Like, I can't say there are bad problems, but also I can't say that there are any good problems. It's a contest. It's fine. Not great, not terrible. Don't know what to say. Like, subscribe, all that stuff. Actually, like, if you are interested in that type of content, join the Discord server. I actually recently started doing streams of me solving some suggested problems, and there were a couple of streams where I was working on my code library, and because of me being me, I don't want to post about that on Kidforces, so I only post about the streams in my Discord server. So if you want to be notified about that, can join the Discord server. I should put the link in the description, and also the link to Buy Me a Coffee site where you can throw your money at me for some reason. I don't think that you should, but you can. Well, that's it for sure. Thanks for watching. Bye.